Okay, sorry about that. Someone came in the room. So let's finish off problem 4. We found that we have y is 50 and the square root of 9 was 3. So our equation now is k over 3 equals 50. If I want to solve for k, I multiply both sides by 3. The 3's cancel, so I get k is equal to 150. Now, if I'm going to vary x, so I'm going to let x go from 9, I'm going to vary y. So y has gone from 50 to 30, so my equation is going to look like 30 equals k, which is 150, divided by the square root of x. Again, if I'm trying to solve this, I can just flip these, which I can do mathematically, so square root of x equals 150 over 30. The square, or 150 divided by 30 is equal to 5. So if this is the square root, I need to do the opposite to find x. So if I were to square this, I get x equals 5 squared, which is 25. So x equals 25 on this problem. Okay, let's look at a little easier way we can do this. Still works, but if we do not have to find our constant of variation, we can set up our problem as my x multiplied by y, which will equal k. Right? Because if the x had been down here, and I multiplied both sides by x, I get x times y equals k. Well, my second x, so here I've changed x, so I'm going to call it x sub 2, meaning the second x, is also going to be multiplied by the second y to equal the same k value. So my equation, if I have two things multiplied together, I can say first x times first y equals my second x times the second y. So in this problem, x is 0.4 multiplied by y is 3. Find x, so I don't know this x, when y is 2. So 0.04 times 3 is 1.2, and that's equal to x multiplied by the number 2. I'm going to divide both sides by 2, so I get x equals 0.6. And again, we can bypass finding our constant variation if I don't need to find it. So if the problem doesn't ask for it, you really don't need to find it. Okay, so again, my first x times my first y. So again, because it's inverse, I can use this equation. So if x is 5, y was 24. Find y when x equals 16. Okay, so 5 times 24 is 120 equals 16y. So divide both of these by 16 and we get that y is equal to 7.5. Okay, oh, a word problem. It's no different. We decide which thing is x, which is y. X is usually the thing that you can control. So the amount of chlorine left in the pool varies inversely to the number of days since chlorine was added. So the number of days since we added it, that sounds like that should be x to me. The amount of chlorine left, that's a function, the pool takes care of that, so that's going to be my y. So if I have 5 units of chlorine after 12 days, so 12 days times number of chlorine is going to be equal to the number of days to the chlorine. So I had 5 days, gave me 12 units of chlorine. And we want to see if after 16 days, how much do we have left? So divide both sides by 16. Now I'm going to plug this in the calculator. 12 times 5 divided by 16. And I get, that doesn't seem right. It's not. 60 divided by 16 is 3.75. So there's 3.75 units of chlorine left in the pool after 16 days. Okay, there you go.